Right. So, as mentioned earlier, we're now getting into Learning Unit 3, right? And if we look at Learning Unit 3, the purpose of this learning unit, or at least the module outcomes, is to critically analyze organizational knowledge and information of an organization. All right, and that's what we're going to be focusing primarily on today. Then the second learning outcome or module outcome is to develop appropriate processes of information gathering to improve business decision making. Okay, this we won't even see this week, probably see next week. And then critically evaluate the ethical values, decisions, and actions guiding the management of information and knowledge in organizations. Something I think we'll see maybe just before your test 2 week. Yeah, somewhere there. Okay, right. So, moving right along. Okay. Learning Unit 3, knowledge organization, systems, practices, and implementation, theme 1, knowledge application systems. Okay, so you realize that there's a lot, or it will seem like there's a lot of repetition in this module. Because we did speak about knowledge management application systems, okay? But here now, they want us to explain how knowledge management systems can assist in a variety of organizational problems, okay? And then to select the appropriate knowledge management system in a given organizational context. And we're going to see that today because we're going to be looking at one or two case studies. After I present, you guys are going to need to read up on one or two case studies from your textbook, and then we're going to discuss them briefly in your second session. All right. So let's move on. Okay. So technologies for applying knowledge. Okay. Knowledge application systems support the process through which individuals utilize knowledge by other individuals. So in other words, they're saying they support the systems that allow us to benefit from the knowledge that he obviously has, that we haven't been involved in retrieving, all right, or developing. Okay, that's what the application systems do. Okay, so we kind of acquire or benefit from his knowledge through these knowledge management application systems. Okay, goes on to say mechanisms and technologies can support knowledge application systems by facilitating the knowledge management processes of routines and direction. Okay. Then finally, here they're talking about how technology enabled by intelligent technologies. Right. So knowledge management application systems are typically enabled by intelligent technologies. And you'll see on the next slide, they begin to talk to us about artificial intelligence. Somebody tell me, what is artificial intelligence? What is that thing? And as always, I'm not looking for a perfect answer, polished academic, structured answer. I just want to hear your thoughts. What is artificial intelligence? And I know some are looking at the slide as we speak, reading off one or two things. That's perfectly fine. What is this thing? I'm sure we've heard about artificial intelligence, right? Almost every other week, somebody's saying something about it, either stating how it's going to take away jobs or talking about how it's going to make life easier, or talking about how it's taking advantage of our data or information, or putting us at risk. It's quite a lot of conversation around artificial intelligence, right? Definitely, definitely. So what is this thing? What do you think artificial intelligence is? Google, guys, Google. I'm sure some of you have ChatGPT on your phone. Use it. Let's utilize it. Oh, to be outside in the sun. Should we do class outside?
Yes.
I suddenly have heard so many voices. At least I know you're here. What do you think artificial intelligence is? Yes?
I don't know, I'd say it's like how do I say, a program that is generated to give you the knowledge that you're looking for when it comes to like, let's say if you want to know how, let's see, how to cook a recipe or something like that. Obviously, AI will make things a lot more easier because it already has the information stored within that program. So now it's just a program that's used for everyday life.
Okay. What do you think artificial intelligence is?
Development of computer systems that can perform tasks differently that are typically done by human intelligence.
Okay. Computer systems that are developed to perform tasks like human beings would. Okay? Thank you for your answers. Ladies, let's get some feminine representation. Others are pretending to be fixing their height. What is artificial intelligence? What do you think it is? I think the gentlemen have broken it down as its core for the most part. We can always add, right? Yes.
If I'm just thinking of the total
Hmm.
and we feel like equipment to gadgets, like you said, that those stuff that humans do, but they just do it better and faster.
Better and faster. Okay. Oh, awesome stuff. Okay. So you guys are all correct. Here it says the science that provides computers with the ability to represent and manipulate symbols, all right, so they can be used to solve problems not easily solved through uh, algorithmic symbols. Okay, right. Earlier, one of the gentlemen highlighted, that they resemble human thinking. Um, and yeah, I think we have all, in one way, shape, or form, been speaking to how it helps solve problems. And you are 100% correct. Robotics as well can help us complete tasks. Okay, so that also does fall into artificial intelligence. I think for me, what I like to use to kind of explain it to myself more than anything is actually machine learning. And you'll see that artificial intelligence and machine learning, those terms are used interchangeably. And they might not be exactly the same thing, but they are very closely related. And with machine learning, what you're saying is that these computer programs that we've set up or developed, they take in information, right? We give them access to unlimited databases, right? And then that information on the databases, they utilize to learn, right? How to fulfill certain tasks or how to compile certain information, get to certain answers with the objective of obviously solving problems, right? So one common characteristic of these conventional computer tasks is their algorithmic nature, meaning they engage precise and logical design instructions to produce a distinct and correct output. And that's where that machine learning is now taking place. All right? You find that with these driverless cars, they obviously take in the information of, okay, what is the road I'm traveling on through GPS? What are the stop signs on the road or the robots. What do they look like? Okay, and then when does it say for me to go? When do I need to stop? Right? What is the speed limit in this area? All right, they take in all that information. So what problem are they solving? Getting a passenger or package from point A to B. Can you see that? So that is what your artificial intelligence or your machine learning is all about. All right, it is either software or robotics developed so as to solve problems. All right, and the reason why we say they resemble human thinking is because we adapt our thinking. We don't just keep on trying the same thing when it doesn't work. We say, okay, that doesn't work, so let's do it this way. Okay? When we acquire new knowledge, we start to do things differently. All right? So again, that's why we call it human-like or resembles human-like decision making. Then, speaking to this artificial intelligence and so forth, we then obviously want to synchronize it with our knowledge management, or we then want to make use of it, this machine learning, in our knowledge management. So you find that we have different ways of applying these knowledge systems, okay? And maybe I think the best thing to do is to actually maybe start here, okay? And here you've got technologies for knowledge application systems, okay? So the first one that you have is rule-based, and we'll go back to it. Then we have case-based reasoning. Then we have constraint-based reasoning. Then we have model-based reasoning and diagrammatic reasoning, okay? Now, all of these are different systems that take in knowledge or utilize knowledge in order to solve a problem. But the manner in which they do that is different, hence why they have different names. So speaking to the first, and now we're going back to rule-based systems, okay? Knowledge-based systems based on rules or models to represent domain knowledge, okay? So we know that certain things have to be conducted in a certain way, right? So in order to use the rule-based system, we use if statements. All right, here they're calling them if-then statements, okay? And we have knowledge engineers, all right? These are the people who have the knowledge, who are the experts, right? And they then obviously will provide the necessary knowledge, okay? Knowledge engineering, obtaining knowledge from a domain expert and making it usable by computers, okay? By making it usable for computers, then everybody can obviously just log into their computer and then obviously try and figure out what must I do in this particular scenario, okay? So to give you guys a practical illustration of a rule-based system, let's say we have a car, right? And that car, it seems to be making some funny noises coming from the engine. Okay, some funny noises coming from the engine. All right, car starts, right? We can go, but there's some alarming, those like popping sounds. Maybe let's call it that. I was about to attempt to try and make those sounds, but I feel like it's going to be an epic thing. We're going to leave that alone. All right. Now we know when we take this to the mechanic takes the car in, and they start to work on a rule-based system to say, okay, the sound is coming from the engine. So the problem is likely to be coming from where? The engine, okay? Then they will then maybe put this in or plug the engine up to some sort of computer system, and they'll start to assess, is the engine able to take in the fuel that it should be taking in? Because remember, obviously, with every car you've got specs, right? And so you know how much this Nissan 1400 is supposed to be taking in, because it's a 2-liter engine and so forth, so forth. Does that make sense? And how much carbon monoxide it should be putting out. So if it is not actually consuming the amount of fuel it should be consuming, then you already know, okay, there must be a problem with the fuel injector, for example. Does that make sense? Then we say, but if it's actually taking in the right amount of fuel, that obviously tells us that no, the problem is not with the fuel intake. Does that make sense? So can you see how we're now making use of a rule-based system? And a rule-based system is assertive. It's either yes or no. Does that make sense? It's either we have a problem with the fuel injector or not. And then that leads us to the next question to say, okay, so if it's not the fuel injector, then what is it? And I know nothing about cars, so I don't know where next to take us. But I'm sure you guys are getting the point. Next thing you'll ask about, are the pistons functioning as they should be? All right, are all the 6 pistons pumping as they should be or turning as they should be? If yes, okay, then it's not the pistons. We move on to the next thing. And eventually you will get to where the problem is. And that's what we call the rule-based system. It's helping us to solve a problem based off of following certain rules. Does it make sense, right? Okay. Now, there's a disadvantage with this thing. Sometimes rules become too many and too large for the program. All right? There could be difficulty in coding, verifying, validating, maintaining, and reduction in efficiency of execution. Okay? So not everything can be dissected into yes or no, for instance. And then obviously, as has been highlighted, there's the whole issue of sometimes there might be too many rules and they might be too large. So that might cause problems for the program. Okay, right. So here now they then want to move on to the case-based reasoning system. Okay. And with the case-based reasoning system, it's slightly different from the rule-based system. Okay. Here they're mimicking human problem solving. Why do we say human problem solving? Because here we're recognizing that not everything is black and white. Not everything is yes or no. Sometimes it requires us to actually sit and think about this. For instance, when we go to court, all right, and someone may have been found guilty or we're still in the process of identifying whether that person is guilty or not. What happens? We have to look at how did we conduct previous cases of a similar nature, right? And then we need to identify what actually happened in this scenario, right? Is it actually similar to the previous cases? And on what basis is it similar? Is it close enough? Or can we apply the previous case to this case? All right? And the previous cases then help us decide what is the solution to the current case. Are you now seeing why we call it case-based reasoning systems or system? Okay, when faced with a new problem, humans search their memories for past problems resembling the current one and adapt the prior solution to fit the current one. Remember here we're saying adapt. It's not a copy and paste. Oh, we did it like that then, so we're going to do it like this now. No, we say, okay, this guy did not intentionally murder this individual. He was actually defending himself. Yes, he used excessive force, but it wasn't like Aubrey who intended to murder this person. I don't know the murderer, by the way. Just using this for example purposes. All right. All right. So should we give him 8 years, like we gave 8 years to the other person? We can't. It wasn't intentional. Okay. Yes, he was wrong in certain respects, but ultimately it would be harsh of us to give the person 8 years. Does that make sense? Okay. Method of analogical reasoning that uses old cases, experiences to solve problems, critical solutions, explain and interpret, and situations. Woo. All right. Help me there.
Anomalous.
Huh?
Anomalous.
Anomalous. Anomalous. Does anyone know what that means? What does anomalous mean? Let's search, let's search, let's search. We're all here to learn. Mandy, do you have it? Does anyone have it?
She has this
Deviating from what is standard, normal, or expected.
Deviating from what is standard, normal, or expected. Okay? Okay. Sorry, did you someone say something?
I don't get that. I don't get it.
I don't get it in that specific sentence, but in the context of what we're discussing, deviating from what is normal or expected, it does make sense because the new problem that we are facing is not exactly the same as the previous problems, but it is related, it is similar. So we're going to deviate and say the solution that we're going to apply to this new problem is not exactly the same. So in other words, we're not going to do things as normal or as expected, but it's going to be somewhat similar. Does that make sense? So we're deviating. Okay. Right. Super. Okay. So here now, they're just talking about the typical case-based knowledge application, the steps, or how this knowledge application system actually works. So firstly, you need to have a library of cases, right? I believe the court system wouldn't be able to function if they didn't have a whole database of cases similar to whatever case they're trying to obviously make judgment on, right? They need reference points. Does that make sense? So here, similarly, you need a library of similar cases. Then secondly, you need to select and retrieve those similar cases. And in that process, you're also assessing how similar are these previous cases that we've selected or looked at to our current situation, because some are not going to be applicable, right? On surface level, you might say, no, murder is murder. But when you start to delve into it, you're like, nah, but this was not intentional, so we can't really actually use that case or this case. Let's try and use a case where, again, the murder that took place or the death that took place was not intentional, it was in self-defense. Does that make sense? Okay. Then we say, okay, based on the current problem, all right? So here, if the current problem and the most similar case are not similar enough, then the solution may have to be adapted to fit the needs of the current problem, which is what we've been speaking to for the longest, to say, we know that, what's that saying? One shoe fits all. Doesn't sound like it. What's the saying, guys? If the shoe fits, wear it. Yeah, there's that one, but no one shoe fits all. I think it's no one shoe fits all. Right? All right. Well, neither of us are English majors, so it's fine. But the whole point is that we can't use a one shoe fits all approach. Okay, we have to assess, is this case applicable? If not, okay, can we adapt the solution and apply it here to the problem that we are currently facing? All right? If we can't even adapt it, then we throw it out completely. Okay? Apply solution and get feedback. After we have agreed that we can adapt the solution, or once we have agreed on the solution that we are going to then apply to the problem, we then obviously apply the problem. In other words, we take action, and then we obviously need feedback to say, how did it work? Was it a good fit? All right, what was the outcome of how we applied this? Was it a success or a failure? Okay, then finally, add newly solved problem to the case library, so that when Kate comes and has a similar problem, guess what happens? She'll have a reference point, because we would have obviously added our solved problem to the case. Okay, the new experience is likely to be useful in future problem solving. Okay, so that, ladies and gentlemen, is what your case-based system is all about. All right. So here now they're just extending that further and saying case-based reasoning systems, all right, case attributes and the solution or outcome is not understood well enough to be represented in rules. Okay, remember, rules is very cutthroat, it's very straightforward. It's either yes or a no. It's either this happened or it didn't. Remember, we say if statements. If Aubrey is 6 foot tall, then he can play basketball. Aubrey is definitely not 6 foot tall. So, can I play basketball? No, it's straightforward. Can you see? There's no, all right, if he's athletic, but shorter than maybe. It's either you are or you aren't. Makes sense? I can see pity on some of you guys' faces. Yeah, it's been a tough life. Still here? Okay. Ration of cases are exceptions to the rule-based system is impartial. Okay, so the rule-based system is impartial. I think we've pretty much highlighted this. It's not one of those, it's either you are or you aren't, it's either it is or it isn't. Okay, then useful, okay, incorporates the solution of newly entered case. Okay, so I think like with I'd imagine in law, I'm not a legal practitioner, so I wouldn't know for sure, but I do believe they use the most recent solutions or the most recent cases when applying previous cases to a case that might have just taken place. So I think that's what they are trying to highlight there, that it incorporates solutions newly entered cases or newly entered solutions to more recent cases. And then methods of adaptation, is used. Steps to combine and derive a solution from collection of retrieved solutions. Okay, which is what we just spoke about. Okay, right. Right. Okay. So I think we'll park it there for now, and I see we have 6 minutes to break. So what I want you guys to do is to read through 2 case studies. There's the SOS, and there's the other one. I will find it now. You guys can do this in groups. You can do it individually. I don't mind. Yeah, there's a Gen Aid and the SOS advisor. And then I want you guys to identify which knowledge application system do those cases speak to. Is it the rule-based? Is it the case-based? What is it? Okay. And that will be it for today. So yeah, you guys can have a look at that, or we can take a break now and then have a look at that after the break.